Hi, ladies and gentlemen. Notes 2.3 are on factoring, and this is part one of our factoring. And we are going to do a review of two different types of factoring. The first type is called factoring by GCF, and then the second type is called factoring trinomials by trial and error. This is some review from last year, but make sure you watch it really carefully because we need to make sure you know how to factor in order to be able to successfully complete the rest of the unit. Okay? All right, so we're going to talk about finding greatest common factors and factoring by GCF. But first we have to figure out how to actually find a GCF. So the first step is to find the GCF of the coefficients. And remember, your coefficients are just simply the numbers that are in front of your variables. So here my GCF would be 24, here my coefficient would be 24. And here my coefficient would be 18. And you guys know how to find GCFs of just regular numbers. So like, for example, if I gave you 12 and 14 and I asked you to find the GCF of these two numbers, the GCF would be 2 because 2 is the largest factor, the largest number that you can divide both 12 and 14 by. Okay, and then looking at each variable base, you're going to find the lowest exponent. Okay, but it has to be in common. And if it's not in common, then it just means that the lowest exponent is 0 and we just don't include it. And I'll explain that to you in a minute, okay? So let's take a look at our first example that we have here. So the first step says to find the GCF of the coefficient. So let's go ahead and do that. My coefficients here are 24 and 18. So the largest number that I can divide 24 and 18 by is 6. And then I'm going to look at each variable base and find the lowest exponent. So my first base that I have here is x. And I've got an x in common over here. So I've got x to the second power and x to the first power. The lowest exponent that's in common is x to the first power. Okay, the next variable that we have, the next base that we have is y to the third power. Here we've got y to the fourth power. So our lowest exponent here is y to the third power, so it'll be 6xy to the third power. And I don't include z because z is not a part of, it's not in common with both of these terms right here. So I don't include it. Technically, it's like I've got z to the 0th power here, and then I can include z to the 0th power here, but anything to the 0th power is 1. So when I multiply this expression by 1, this term by 1, I get the same answer, so it stays the same. I don't have to worry about it. And so this right here is my GCF. Okay? Let's do the same thing for the next example. 21a cubed b to the second c, and then 14bc. So right here, 21 and 14, the greatest number that's in common with 21 and 14, the largest number I can divide them both by is 7. There's no a in common with both of my terms, so I don't include it in my GCF. Here I've got b to the second power and b to the first power. B to the first power is my lowest exponent, so that's what I would include, but I don't have to actually write that first power. And then here I've got c, and I also have c, so I've got 7bc. And that is going to be my GCF right here. Okay, so now let's talk about what happens when we actually want to factor by GCF. So steps to factor by GCF. The first step is to find the GCF of all the terms, which we just talked about how to do right here. So it's the same process, okay? And then you're going to divide each term by the GCF. Finally, you're going to write your answer as the GCF multiplied by the quotient, and I'll explain to you in a minute what that means. But basically, all I need to do right here, again, is find the GCF of my terms. So first thing I'm going to do is I'm going to look at my coefficients. My two coefficients here are 25 and 45. So the largest number I can divide 25 and 45 by is 5. Okay, then I look at my x squared and my x to the third power. There's x's in common with both terms, so I include x in my GCF, but I actually want to include x to the second power because I'm looking for my lowest exponent, okay? There's no y in common with both of these guys, so I do not include a y in my GCF, all right? So now the next step says to divide each term by the GCF. So I'm literally going to take 25 x squared y, and I'm going to divide it by 5x squared. So 25 divided by 5 is 5. X squared divided by x squared is 1. 5 times 1 is 5, so I don't have to write it down. And then y is being divided by, no y is here, so technically it's being divided by 1. So anything divided by 1 is itself, so I get 5y here, okay?
I'm going to do the same thing with this next term. So it's 45x to the third. I'm going to divide it by 5x squared. 45 divided by 5 gives me 9. And then x to the third divided by x to the second. Remember, when we divide, we subtract our exponents. So this is x to the first power. Close your brackets, and then you are done. Now, how do I know that I did this right? There are two ways that you can check. Essentially, when you are factoring, really what you're doing is you're just undistributing. That's all you're doing. So we learned how to distribute already. Now we're just going to undistribute when we factor. So one way that I can check is to distribute this 5x squared through. So when I do that, I end up getting 25x squared y plus 45x to the third power, and it gives me the original answer. Now be careful, don't circle this as your answer, because this is the original problem. Your actual answer itself is this right here. Okay, that's just to check to make sure that it's right. Also, so it's going to be equal to that. Also, look inside of your bracket and look at your quotient right here. And this is why we said it's the GCF times the quotient. The quotient is the answer that you get when you divide. There's nothing in common with this term and this term, so I know I took out the greatest common factor. If there's something in common with these two terms, then you did not take out the greatest common factor. Okay? All right, let's take a look at our next example. Same thing. We're going to just follow these steps. Find the GCF of the terms. So first thing I'm going to do is look at my coefficients. My coefficients are negative 32 and negative 64. Always take the sign of your leading coefficient when you factor out. It's not wrong if you don't, but it's easier if you actually factor out a negative right here. So I'm going to factor out negative. Remember, copy the sign down of your leading coefficient. Here my leading coefficient was positive, so I've got a positive here. So this is going to be equal to negative. Now the largest number that I can divide 32 and 64 by is 32. Okay? And then I'm going to look at my variables. A to the fourth power, a to the first power. A to the first power is my lowest exponent, so that's what I'm going to look for. Then when I factor it out, negative 32 divided by negative 32 is 1. A to the fourth divided by a is a to the third because we subtract our exponents. Negative 64 divided by negative 32 is positive 2. And then our a's cancel out to give us 1, but we don't have to write 2 times 1 because it's just 2. Then I can close my brackets. How do I know I did it right? Well, first of all, there's nothing in common with this term and this term, so I know that that's correct. Second of all, when I actually go through and I distribute this through, I do end up getting this as my answer right here, so I know that I did it correctly. So this is my final answer here. Okay, I want to go over one last example with you guys, and that is 7x squared y plus xy. How do I factor this out right here? So first of all, my coefficients are 7 and 1, and there's nothing in common with them, so I'm not going to include a coefficient in my GCF. It's just 1, okay? But they do have x's in common, and they do have y's in common. Okay, so when I factor this out, 7 divided by, or technically there's a 1 here, right? 7 divided by 1 is 7. X squared divided by x is just x. And the y divided by y gives me 1. I don't have to write it down because there's already a term here. Now, right here, when I divide x by x, I get 1. Y by y, I also get 1. This time I have to write down a 1, otherwise there's nothing there. Here I don't have to include the 1 because when I multiply 7x by 1, I get 7x. There's still a 7x here. But here I need a 1 to show that when I divide this by this, I end up getting a 1. Without it, without having that 1 there, if I thought my answer is this, when I multiply it through, I only get my first term. I do not get my second term. So one thing to note is however many terms you have here is however many terms you should have in your quotient inside of your brackets right here. So this is my answer. Okay, and that's how you factor by GCF. Let me know if you have any questions. Okay, now we're going to talk about factoring trinomials by trial and error. But first thing I want to do is I want to go through and multiply this together with you. So if you look right here, we end up getting 2x times 3x we know is going to be 6x squared. 2x times 1 ends up giving me 2x 5 times 3x ends up giving me this 15x right here, and then 5 times 1 ends up giving me 5. So really what ends up happening right here is I end up getting the 6x squared, and then these two combine together to give me 17x, and then this 5 just gets copied down. Now I want you to notice something interesting about what happened here, in case you haven't already noticed this. So if you notice, the 6x squared, my ax squared term, don't forget that the general format is ax squared plus bx plus c. So this ax squared term comes from multiplying your firsts together. 6x squared comes from multiplying 2x by 3x, okay? And then your c term comes from multiplying 5 and 1 together, so you end up getting 5. But the bx term came from doing what? It came from multiplying your outer and your inner together. Okay, so give me 1 second to just color code this right here for you guys. So again, the bx term came from this term right here and this term right here. Okay, so when we want to factor by trial and error, we want to do the same thing. We're going to undistribute. We're kind of like we're going to unfoil here, okay? So let's go ahead and try this and see what ends up happening. So I know for a fact right here that this has to be x and this has to be x because x times x gives me the x squared that I want. And I also know that my last term in each bracket will multiply together to give me 24. So let's look at some factors of 24. I know I can do 1 and 24, 2 and 12 will work, 3 and 8 will work, and 4 and 6 will work, okay? And since this is 1x, this is a little bit easier, right? So I'm going to look for two factors that will multiply together to give me positive 24 and add up to give me negative 10. So I know that this and this are out because there's no way that 1 and 24 can give me 10, and there's no way that 3 and 8 can give me 10. So I'm left over with 2 and 12 or 4 and 6. Now, if I were to use 2 and 12, the only way I can get a negative 10 is if I use positive 2 and negative 10. But when I multiply them together, negative 12, excuse me. But when I multiply them together, I get a negative 24, and I want a positive 24. So I know that for a fact that that won't work. So we can cross this guy off right here. So now let's see, how can I get a negative 10 from a 4 and from a 6? Well, if I have negative 4 and negative 6, that multiplies together to give me positive 24, but it adds up to give me negative 10 exactly like I want, so that will work for me. Let me just do a double check just to make sure. So this gives me negative 4x, and this also gives me negative 6x. When you add them together, you get the negative 10x that you want, so you are good to go. So this is our final answer right here, okay? So let's do something similar with this next question right here. So if I have 28p squared plus 15p minus 25. So I know for a fact right here, and I'm just going to erase this chart right here so we have a little bit of room, that my first term in each set of brackets needs to multiply together to give me 28p squared. Now, since this is trial and error, we're going to have to do a lot of guess and check and erasing, okay? So let's go ahead and look for factors of 28. So we know we've got 1 and 28. We know 2 and 14 will work. 3 doesn't work. 4 does work, 4 and 7. 5 doesn't work, neither does 6. 7 works, but now we're repeating, so we've listed all the different possibilities, okay? So that's what our possibilities are going to be for my ax squared term or my ap squared term in this example. Now, I also know that my final terms in each bracket will multiply together to give me negative 25. So I'm going to make a list of factors of 25. So that one's not so bad. It's just 1 and 25 and 5 and 5. Now I'm going to play with all the different combinations of what I have in purple and blue here until I get this 15p that I want in the middle. So I'm going to start with 28p and 1p. And again, with more practice that you get, you're going to see maybe I don't want to start with those numbers because this number right here isn't very large and 28 is a large number. But let's see what ends up happening. So if I put the 25 here and the 1 here, when I do my check for my outer and my inner. I know this is 1p, and I know this right here is going to be a majorly large number, nowhere near 15p, so I can cross that off. It doesn't work. But I need to try to see if maybe I can switch these values. So maybe I can put the 25 here, and I can put the 1 here, and let's see what we end up getting. So this will give me 25p, this will give me 28p, but neither of those numbers can combine together any way to give me 15p, so I know that that won't work either. Okay, so let's try another set. 1 and 25 won't work with 1 and 28. So now let's just try 5 and 5. Let's see if 5 and 5 will work. So I'll put a 5 here and a 5 here. This one right here is going to give me, again, a large number. It'll be 140, which won't get me anywhere near 15p, so I can just cross off this 5 and 5. There's no need to switch them, because when I switch them, they look exactly the same. So I know for a fact that 28 and 1 just are not going to work. So now let's try 2 and 14 maybe and see what we can get from the 2 and the 14 right here. So if I put 2p here, and let's put 14p here actually, and 2p here. Let's go ahead and try some of our factors of 25. So if I put 25 here, it'll be too large. So let's try 25 here and 1 here. So this will give me 50p, this will give me 14p. I can't get a 15p somehow from there, so I'm not going to worry about that at all. Okay, so let's go ahead and try 5 and 5. So if I put a 5 here and a 5 here, this will give me 10p, this will give me 70p. Again, it's just not going to work for me, so I know that 2 and 14 is not a good combination, so I'm going to cross those off. So now let's try 4p and 7p. So let's see what ends up happening with our 4p and our 7p that we have here. So if I were to put 4p here and 7p here, and let's try 1 and 25 again. I probably don't want to have double p's there. So let's put 25 here, and let's put 1 here. This ends up giving me 7p, and this ends up giving me 100p. It doesn't give me the 15p that I want, so I'm not going to use that example. But maybe if I switch them, it'll be a little bit better. But it's not, because if I were to put the 25 here, now I'm going to do 25 times 7, which is even bigger than 25 times 4. So that just is not going to work. So we've exhausted all possibilities except for our 5 and our 5, and hopefully that will work for us. So let's go ahead and try this and see what we end up getting. So 5 times 7p gives me 35p, and then 4p times 5 gives me 20p, and I can get a 15p if the 20 is negative and the 15 is positive, which will work for me, which means that since this 35 is positive, this 5 must be positive, and this since this 20 is negative, this 5 over here must be negative. Again, don't forget your equal sign. I keep forgetting it. So this is going to be your final answer right here. Okay, I know that 4p times 7p is the 28p squared I want. 5 times negative 5 is negative 25. And then this 35 and this negative 20p's add up to give me positive 15p. Okay, last example of trial and error. Even though there's a lot of different variables in this example, it's exactly the same process. So we know that when we factor it right here, the first term in each set of brackets will multiply together to give us 8x squared y squared. So I'm going to look for factors of 8. Okay, so some factors of 8, that's nice and easy, just 1 and 8 and 2 and 4. Okay, and then we also know that the last term in each bracket will multiply together to give me negative 15z squared, right? So some factors of 15 are also nice and easy. There aren't too many of them, so we can try 1 and 15, and we can try 3 and 5, okay? So when you get more practice with this, you're going to end up figuring out what the trials that you want to use are going to be. Just by experience, you'll understand which ones will work better. So I think I'm going to try 4 and 2 and see what ends up happening. but I need 8x squared y squared. So although 4 times 2 is 8, I need an x and an x, and I need a y and a y to end up getting my x squared y squared. I think this is going to work. I mean, technically, I could have an x squared here and a y squared here, but I'm going to try it like this because this has an x, y, z in it. So I have a feeling that they both need to have x's and y's in it. And because it's a trinomial, so I want my variables to be the same here. Okay? So now let's try putting in some values for factors of 15 here. So let's go ahead. I'm going to try to put a 3 here, and I'm going to try to put a 5 here. But again, remember, we want z. So I'm going to put a z and a z. So let's go ahead and test. So this ends up giving me 6xyz, and this ends up giving me 20xyz, which does not give me the 2xyz that I'm looking for. So I'm going to erase this, and I'm going to erase this, but I'm going to just swap them and see if that works for me. Okay, so instead of putting the 3z here, I'm going to put the 5z here. And then I'll put the 3z in this spot. So this right here, this middle term, ends up giving me 10xyz, and this outside term right here will end up giving me 12xyz, which is exactly what I want to get this 2xyz if this 10 is negative and this 12 is positive. So it works for me. So since this 12 is positive and it leads us to this 3z, we know this is a plus sign. And since this 10 is negative and it leads us to this 5z, we know this is a minus sign. And that's our final answer.